Hello, hello, can you hear me? Hello, 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 can you hear me? Hello, 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 dear students. Anybody is there on the live stream? You can show thumbs up if you joined live stream. Live stream is on now. Okay, all ICSE students, ನಮಸ್ಕಾರ ಸ್ಥಿತಿಗೆ ಬನ್ನಿ. ಇದನ್ನೆಲ್ಲ ಅಭ್ಯಾಸಗಳನ್ನು ಏಕಾಗ್ರಚಿತ್ತದಿಂದ ಶಾಂತ ಮನಸ್ಸಿನಿಂದ ಮಾಡಿ ಮುಗಿಸುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಕಲಿತ ವಿಷಯಗಳನ್ನು ಜ್ಞಾಪಕದಲ್ಲಿಟ್ಟುಕೊಳ್ಳುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಜ್ಞಾಪಕದಲ್ಲಿರುವ ವಿಷಯಗಳನ್ನು ಪರೀಕ್ಷೆಯಲ್ಲಿ ಸರಿಯಾಗಿ ಬರೆಯುವ ಬುದ್ಧಿಶಕ್ತಿಯನ್ನು ಕೊಡಲು ಇಷ್ಟ ದೇವತೆಗೆ, ಗುರು ಹಿರಿಯರಿಗೆ, ಕುಲದೇವರಿಗೆ ಪ್ರಾರ್ಥನೆ ಸಲ್ಲಿಸಿ. ಟೇಕ್ ಡೀಪ್ ಬ್ರೆತ್ಸ್. Yes, good evening, my dear students. ICSE, it is a ICSE class 10. Students can join this class at 9 p.m. Class 10 ICSE. Students can join this live stream. This is for you. Myself, Icse, your chemistry maths trainer. It is a course, not a just a live stream. I will be preparing you for the annual exam. And one thing ICSE students should remember is that to score good number of marks, just reading is not sufficient. Reading is to understand the concepts in mind. And then immediately you go on solving questions like I started last class. The periodic properties. We studied already the periodic properties, atomic size, then metallic character, non-metallic character. How do they vary along the period and down the group? Why they vary along the period and down the group? Up to 4 periods, you must be perfect. What is the first period? As per the ICSE guidelines, you must know the elements, periodic properties you have to study with reference to period 1, period 2, period 3, period 4. In groups, you have to take alkali metals with reference to, they have clearly mentioned in the syllabus with reference to alkali metals, most electropositive and halogens group. In groups, you have to remember these. In the periods, you have to remember first period. First period consists of only 2 elements, hydrogen and helium. Second period starts from 1 to 2. Second period consists of lithium, beryllium, boron, carbon, right? Then you have oxygen, nitrogen first 7, 3, 4, 5, atomic number 6, 7, 8, 9, 10. Only 4 periods you are expected from the board. Oxygen, fluorine and neon. Don't go beyond 4th period. And third period starts from sodium, atomic number 11, 12, 13, 14, 15. You must know their symbol, atomic number clearly. 18. Now you have the elements here. Atomic number 12 will be magnesium. You must have clear understanding about it. Aluminium, 14 is silicon, 15 is phosphorus and sulfur, atomic number 16, 17 is chlorine, 18 is argon, inert gases. Last period 4 starts from atomic number 19, that is potassium, right? And 20, you can take 21 starts here, 22, 23, 24, 25, 26, 27, 28, 29, 30, these 10 elements. Then up to potassium, atomic number 19, 20. First you make the elements perfect. Calcium, fill in the blanks. Here you must be very interactive, right? You must have clear understanding of the elements in the periodic table. The elements 30, you have 31, 32, 33, 34, 35, 36. Completes the third period, fourth period. As per the Icse syllabus, students must be perfect in 4 periods. You need not go beyond 4th period, only up to 4th period. At least you must know the name of the elements. What is the name of the element with atomic number 21? Scandium. And 22 is a titanium, vanadium. 23, 24, chromium. 25, manganese. 26, iron. 27, cobalt. 28, nickel. 29, copper. 30, zinc. Next, P block starts. 31, element with atomic number 31 is gallium. 32, germanium. 33, arsenic. And 34, selenium. 35, bromine. 36, krypton. Only up to these elements you have to make perfect. Yes, good evening. Good evening. Good evening. Thank you. Thank you. Thank you for your comments. Thank you. Thanks for your everything. Thank you. Thank you. Okay. So see here, as per the ICSE recommendation, you have to know all these elements in the period, 4 periods, all elements, at least atomic number and symbol you must be perfect. Then you have to know variations, how the atomic size changes, how the metallic character changes, how the non-metallic character changes. You have to understand along the period first. Now you remember this thing, atomic size. I will give the theoretical concept, again I will go to questions. Now what is my suggestion for ICSE students is, most of the questions will not be lengthy for you, but they will be tricky. They will test your skill, application ability. Therefore, just studying book is useless. And after studying the concepts, definitions, you have to start answering the questions appeared in previous year, or in text questions, end text questions, workbooks. Refer at least 2 to 3 books. Okay. And apart from your school books, I'll refer different books and give you atomic size. How does atomic size changes along the period? Atomic size along the period, how it changes and why it changes along the period. Before I start questions now, my teaching for ICSE will be through questions. Okay, once you learn the theory, get ready for the questions. Along the period, what happens? Atomic size decreases from left to right. Left to right. You must have clear understanding. It decreases. Why it decreases, we discussed in the last class. Again, I will take questions and again explain you. Along the period decreases. Name the elements. Which particular elements have got the highest atomic size? highest atomic size will be alkali metals, that is group 1 elements. Group 1 elements. I will rub this part. I think you noted up to 36. Sufficient. As per the instructions of the Icse board, only up to 4th period you must be taught in groups with reference to alkali metals and halogens we have to study. Alkali metals are placed in the group 1. Let us finish the period now. Along the period, atomic size decreases. And you must now clear knowledge of why it decreases. Already we discussed in my previous videos, live classes, you can see it. Alkali metals start from lithium, not from hydrogen. Hydrogen is a non-metal. Lithium, sodium, potassium, atomic number 3, sodium atomic number 11, potassium atomic number 19. Okay, then you have rubidium, 37, rubidium, cesium, 55, francium, radioactive, alkali metal. It is not taken as alkali metal, leave it. Only lithium, sodium, potassium, rubidium, cesium. Radioactive elements, don't include them. Halogens start from fluorine, atomic number 9. With reference to alkali metals and halogens, you are supposed to study down the group, the periodic properties. Fluorine. Next you have chlorine, atomic number 17. Next you have bromine, atomic number 53. Next you have iodine. Bromine 35. Because the next inert gases will be neon 10, argon 18, neon 10, argon 18. Then you have krypton 36, iodine 53, because the 54 is xenon. And only these you can remember. Iodine, you have astatine with atomic number 85, and 86 will be radon. Only remember them, because you need not consider radioactive elements. So down the group, what happens to the atomic size? Atomic size along the period, left, right, along the period decreases. Remember, down the group, atomic size increases. In detail we discussed about it. First periodic property we studied. You must know what happens first and why it happens. Next we discussed in detail. Just keep it in your mind. Second thing is got as a metallic property. To try to understand metallic property. So metallic property, if you go along the period, from left, right, along the period, if you take a first period, second period, third period, fourth period, just now I explained you. Metallic property along the period. So metallic property meaning what? Metallic property, meaning of metallic property is ability to readily lose electron. Tendency to lose electrons readily. Tendency to lose electrons and form positive ions that is N plus metals. This is metallic property. This metallic property from left to right along the period goes on what? Along the period, what happens to the metallic property? Along the period, what happens to the metallic property and why it happens? Along the period, metallic property decreases. Right? If you take as an example, period 3, period 2 you can take, period 2 also you can take. The elements are lithium 3, 4, 5, 6, 7, 8, 9, 10. If you take lithium, 4 is beryllium, 5 is boron, 6 is carbon, 7 is nitrogen, 8 is oxygen, 9 is fluorine, 10 is neon. If you observe here, lithium, beryllium, boron are metals. If you come to carbon, nitrogen, oxygen and fluorine are called as non-metals. Non-metals. Why this is happening? Why these particular lithium, beryllium, boron are metals? Why the metallic property goes on decreasing from left right along the period? And if you come down the group, these are alkali metals. Down the group, what happens is metallic property goes on increasing. Remember, metallic property, this is along the period. If you take down the group alkali metals, you try to understand the concepts clearly. Metallic property, remember, increases. Down the group. Why this is happening? We'll try to understand it again. Atomic size, I explained you, and I want to clearly once again explain you why the metallic property changes. And non-metallic property. What is a non-metallic property? Non-metallic property is a tendency to gain electrons. See, the third property we have seen is that non-metallic property. Non-metallic property. Carefully understand. Non-metallic property. The non-metallic property, if you see along the period, what happens? See, this was metal, these are pure metals. Lithium, beryllium, metallic property, boron will be less. Carbon is a total non-metal, nitrogen is total non-metal, oxygen non-metal, fluorine non-metal, neon is inert gas. They are independent family. They are chemically not reactive, they don't involve in this particular thing, therefore they are separate group. And even you can take neon also non-metal, they are neutral. So why this is happening? Non-metallic property along the period, what happens? Non-metallic property. Along the period, non-metallic property increases. Remember, down the group, non-metallic property decreases. We'll try to understand it logically. They will not ask you the values, but you are asked reasons. Let me explain you again by taking the two concepts. Why metallic property? I hope you understood these things. Remember correctly, metallic property along the period decreases. Along the period decreases, down the group increases. Reason why? Non-metallic property along the period increases, down the group decreases. Why? We try to understand logically. Look at here. What happens? Let me explain you again. Just remember the concepts clearly. If the concepts are clear, then you can answer the application questions carefully, because most of the questions in the new pattern, right? So they are based on that. Why metallic property along the period? Look at here. Along the period, metallic property increases, down the group decreases. Metallic property increases, metallic property decreases from left to right, increases from down to group. It increases down the group. Carefully understand. Why the metallic property decreases is, observe here, what happens to the atomic size? Atomic size, what happens is, from alkali metals, if you continue, atomic size goes on decreasing. Okay, I am not taking in particular any element, just I want to show you. Atomic size, if it is bigger, see, look at here. Here radius is still smaller, radius is still smaller, smaller. Just logically you understand. What happens when the atomic size is large means between nucleus and the valence electron is away. This electron in the valence shell is away from the nucleus, means nucleus will have nuclear charge. Nuclear charge, atomic radius will be highest and it will go on decreasing. See the distance between the nucleus and the outermost electron, what happens? As the size is more, this electron is more free. Just now I told you that metallic property is a tendency to lose electrons. Suppose M is a metal, its a metallic property depends upon how many electrons it can lose. Suppose that it readily loses n electron, this becomes Mn plus n electron. So say you can take sodium. Sodium becomes Na, loses one electron and readily loses one electron, liberates one electron. Therefore, it is highly reactive and pure metal. Highly metallic property. Highest metallic property is observed in group 1 metals. They are highly reactive metals. Means more the ability to lose electron. Why is sodium placed in the group 1? Alkali metals readily lose because their size is big. Means the distance between the nucleus and the outermost shell is more. Therefore, this electron by supplying little energy, if you supply little energy, you can remove it. Therefore, at the room temperature in the cold condition only, sodium when put in water, it readily reacts. Therefore, sodium metal is stored in kerosene, not in water. You cannot put it in air. It is a grey colored metal stored under kerosene, can be cut with a knife. Why this happens? Because this sodium in the valence electron is far away from the nucleus. Therefore, control of the nuclear charge, positive charge, influence of the effective nuclear charge, influence of nuclear charge is less. Therefore, electron can be easily removed. Now see, like parents, yesterday I gave you example, parents and students, or teachers and the students, and the distance between the parents and the students is more, then the students become what? More free. They do whatever they want. If they are very close under the control of the parents, then to remove this particular student for a movie, to take your friend to a movie, you can easily take if it is away from home, staying in some other place. Now, as the size decreases along the period, this outermost electron comes closer and closer to the nucleus. Therefore, this influence of nuclear charge on the electron goes on increasing. Therefore, you need to require more energy. Suppose that you have to supply 10 joules here. Suppose that you want to supply 5 joules to remove this electron. Here, electron required to remove maybe 10 joules. More energy is required because it is under the control of the nucleus. And as you go move further, the nuclear charge influence will go on increasing. See, because one proton increases, nuclear charge is increasing, and therefore they will pull the valence shell towards themselves. Therefore, they are under the more control. Therefore, to lose electrons is difficult. That is the reason as to why metallic property decreases from left to right. Lithium is a metal, beryllium is a metal, boron is a metal, but carbon is a non-metal, nitrogen is non-metal, oxygen is non-metal, fluorine will have still smaller size, and suddenly inert gases becomes a larger size. You can observe, I explained you in the last period. I hope you are understanding the meaning. Therefore, these metals, particularly lithium, beryllium, boron are metals because the distance between the nucleus and the outermost shell is more. Therefore, the electrons can be easily kicked out by supplying little energy. Therefore, they have tendency to lose electrons. After carbon, non-metals will begin. Right? So, metallic property goes on decreasing along the period. I hope you understood. Similarly, what happens with the non-metallic property? ಅದನ್ನೊಂದು ಹೇಳಿಬಿಡ್ತೀನಿ ಇಲ್ಲೇ ನೋಡ್ರಿ, non-metallic property increases. What is the non-metallic property? I will take non-metallic property. Carefully understand. I will try to clear you the concepts. If your concepts are not clear, you can ask me the doubts. Non-metallic property. Observe here, non-metallic property means tendency to gain electrons. Andre, the meaning is that these are givers of electrons, donors of electrons. But these non-metals are, they are acceptors of the electrons. They have tendency to gain electron, tendency to gain electrons. For example, if you take the non-metal here, fluorine, right? Fluorine can gain one electron and form a fluoride ion. Oxygen gains 2 electrons and form an oxide ion. Nitrogen gains 3 electrons and form a nitride ion. Carbon can gain 4 electrons and form a carbide ion. Look at here. And lithium has got tendency to lose electron. Beryllium has got tendency to lose electron. Even boron can have the ability of both lose electrons. Right? These are non-metals have the tendency to gain electron. Why do that? Means non-metallic property goes on decreasing along the period. Decreases along the period. Sorry. Metallic property decreases, non-metallic property increases along the period. Try to understand why it is increasing. Logically, you try to understand. Now, what is happening here is nuclear charge is more, goes on increasing, means what? This nucleus will have an ability, due to the nuclear charge, can hold an extra electron on it. Because nuclear charge will have the ability to gain and hold extra electron on its surface. Therefore, observe, fluorine can gain 1 electron because of the nuclear charge is more, positive charge of nucleus, that is nuclear charge is more. Due to the effective nuclear charge is more, these elements, say that is carbon, you can take carbon, nitrogen, oxygen, fluorine, and their atomic size is also less and nuclear charge is more. Therefore, they have got ability, carbon has got ability to hold 4 electrons. Nitrogen has got ability to hold 3 extra electrons. Oxygen has the ability to hold 2 more extra electrons. Fluorine has ability to hold 1 more extra electron. This tendency to gain electron increase because effective nuclear charge, increase in the effective nuclear charge will have the ability to gain electron and hold it. But these do not have that ability, metals. Therefore, this non-metallic property increases from left to right along the period. I hope the metallic and non-metallic property concepts are clear to you, my dear students. You try to understand these concepts clearly. Okay, now we'll see down the group. Let me clear you. What I told is metallic property is the tendency to lose electron. Non-metallic property is the tendency to gain electron. From left right along the period, the reason for this is left right along the period, atomic size goes on decreasing, nuclear charge goes on increasing. See, as the distance between the nucleus and the outermost shell is less, in case of the metals, lithium, beryllium, boron, these electrons, they have tendency, ability, easily they can lose electrons. Means this reaction of losing electron is called as oxidation. Gaining electron is called as reduction. You studied in earlier, oxidation reduction. Later we will talk about it. See, this is the thing. And they have tendency to look, as you move further, what happens is metallic property goes on decreasing because the electron cloud will come closer and closer, nuclear force will increase, like parents will be very, very close to the students. Therefore, students are tightly bound to it. and therefore they cannot be lost easily. And if you see non-metallic property, tendency to gain electron, it increasing along the period. Why? As you move further, if you come to here carbon, nitrogen, oxygen, fluorine, due to the increased nuclear charge, a decreased atomic size, nucleus can hold extra electron on it. If the electron is donated by some other element, they have ability to hold the electron. So therefore, this tendency to gain electron is called as a non-metallic property. Therefore, non-metallic property is increasing along the period. Metallic property is decreasing along the period. I hope concepts are clear. What happens down the group? That one I will explain you clearly today. So next period again we will solve attempt questions. You start solving in text questions, end text questions. How many questions you attempt? That is very important. Answers are not lengthy, very short answers. Test your skill and application and understanding. So down the group what happens? See, down the group what happens is at every period, first period, second period, third period, fourth period, if you take, we are interested in only 4 period. What happens? A new cell is introduced. Here how many cells are there? Suppose I take this one as a nuclear charge and only one cell is there in the first period. What happens in the second period? In the second period, what happens is K cell and L cell, 2 cells are introduced. What happens in the third period? We are interested in only, but nuclear charge will also increase, size also increases. Here, third cell will have how many cells? It will have 3 cells. Are you getting me? Let me draw. Smaller. Here, only K cell will be present. Here, in the second cell, what will be there? It will have K cell as well as L cell. If you come to the third period, it will have nuclear charge will be more. But cell 1, 2, 3, sudden increase in the cell. If I take a 4th cell, it will be further more. It will have 4 cells, 4th period. 1, this is K cell, L cell, M cell and N cell. Observe carefully. Down the group, if you go, what is happening to the size? Size is suddenly increasing. Means distance between the nucleus and the outermost shell, distance between the nucleus and outermost shell, distance between the nucleus and electron in the outermost shell is increasing more and more. Means students are going more and more away from the parents. What should happen? If I take down the group, lithium, sodium, potassium, rubidium and cesium. This is present in second period, third period, fourth period, fifth period, sixth period. Now size is continuously increasing. Means as the size increases, average distance between the nucleus and the electron is less here, more here, furthermore, most here. Means the electrons becomes more and more away from, means little energy is required to remove cesium, right? And here lithium to cesium, if you come, what happens? The distance between the nucleus and the outermost shell increases. Therefore, lithium, sodium can more readily give. Sodium can more readily, it is more metallic than lithium. Potassium is more metallic than sodium. Rubidium is more metallic than potassium. Cesium is more metallic than rubidium. Therefore, cesium is the most metallic property. What is the decreasing order of metallic property? Cesium is greater than rubidium. Rubidium is greater than potassium. Potassium is greater than sodium. Sodium is greater than lithium. This is the decreasing order or decreasing order of metallic property. Therefore, down the group, metallic property, down the group, yes, metallic property increases. Note it correctly. Metallic property increases down the group. Only reading is not sufficient. Thinking is important. Why? Why? Because distance between the nucleus and electrons, larger the distance, easier will be the electron to give out. Therefore, cesium most readily gives electron. Rubidium will be less than cesium. This is called as electropositivity. Cesium has got highest. Next comes rubidium. Next comes potassium, sodium, lithium. Therefore, metallic property is like this. Means metallic property down the group goes on increasing. Now, what happens to non-metallic property? What happens to non-metallic property? Non-metallic property. What is the non-metallic property? Just now I told you that non-metallic property is the tendency to hold the electron. See, if an extra electron, now as you move down the group, distance between the nucleus and the outermost electron is more. Means this nucleus has no control over its own electron, then how it can gain extra electron and hold it? I hope you are getting me. If a parent cannot look after his or her own child, how it can adopt any other child? No, that capacity will not be there. Therefore, non-metallic property, it has no ability because of the distance. Nuclear charge will have no influence on it. Therefore, non-metallic property decreases. Understand clearly. Non-metallic property decreases, metallic property goes on increasing. Even you can take the halogens. Halogens, if you take fluorine, chlorine, bromine, iodine, let us take astatine. If you come down the group, what is happening? New cell is introduced. Means the size of fluorine will be less, chlorine will be more, bromine will be still more, iodine will be still more, astatine will be still more. What happens? What happens? The nuclear charge, atomic size will be more. Then nucleus will have less ability to hold the electron. Right? So if I want to write correct decreasing order of the non-metallic property, which has got a highest non-metallic, down the group if you say, which is a decreasing order of the metallic, non-metallic property which is most non-metallic, fluorine is more than what? Chlorine. Why? Atomic size is more, therefore its ability to hold the electron will be less. Bromine. Fluorine has highest non-metallic property. Chlorine next. Next comes bromine. Next comes iodine. Next comes astatine. Means down the group what happens is metallic property goes on decreasing. This is called as a decreasing order of non-metallic property. Decreasing order of non-metallic property. You will be asked in MCQ. Non-metallic property. I hope you understood the concepts, my dear students. I hope I have cleared you the concepts. That is, three periodic properties we completed. One is atomic size. Second one is a metallic property. In detail I have discussed today. And next one is non-metallic property. Next period I will come with more questions, tough questions, application questions on these three properties. Then we will continue with the two more properties. One is ionization potential, another one is electron affinity. If you study that, the chapter will be completed. Then we will have a test. Okay. Tomorrow, I will remind you carefully. Tomorrow is a mathematics last combined class. Then a mathematics class will be separated. CBSE, state and CBSE will be one batch. ICSE will be at your own batch. Tomorrow, one period test between 8 to your class is between 8 to 9. I will send you paper at 7 p.m. Please note it. Tomorrow, trigonometry test. Trigonometry test. I will rub this, note down correctly. Don't get confused. I will put it in the WhatsApp group also. Trigonometry test. So in the WhatsApp group, I will send you test paper. Mathematics subject is trigonometry, 20 marks. And 45 minutes test will be there, covering up to identities, trigonometric identities, trigonometric ratios, standard angles, study them correctly, and identities, trigonometric identities. On that we solved problems between 8 to 9 combined we are taking. tomorrow is the last combined class, then I will separate the classes. See, the time is at in your WhatsApp group, that is Logzi ICSE WhatsApp group. I will send the paper at 7:30 p.m. PDF I will send you. PDF. You have to, in the long sheet you have to solve. I will come live at 8:15 p.m. to 9 p.m. There will be evaluation, that is discussion of the paper and self-assessment. You have to do self-assessment without cheating. Self-assessment of the paper. Then you have to send your marks in the group. Join WhatsApp group. Links are available. In the WhatsApp only I will send the PDF at 7:30 p.m. Right. Then at 8:15 to 9 p.m. I will discuss the paper along with scheme of evaluation. Then you can make the self-assessment. I will go on giving you scheme of evaluation. You solve them and self-assessment. At the end you have to upload the marks. After tomorrow class, maths period will be separated, right? Like a chemistry period now, right? Like chemistry period. 9 to 9:45 will have maths period, and as usual 9 to 9:45 no combined class. This is the last combined test. After that I will separate the classes. Then again I will combine. Okay, we'll continue in the next class tomorrow. Write the test. I'll give the details in the WhatsApp. Okay, if you like Logzi classes, my explanation, please subscribe, ask your friends, relatives, and anywhere, let them join as in the live stream, actively participate here. It is not a YouTube channel, it is a course. I am not a YouTuber, I am your teacher. You are not my subscribers, you are my students. That's all, my dear students. Bye bye. See you tomorrow. All the best for the first step.